The first oceans, how water came to Earth. Take a moment to imagine the boundless beauty of Earth's oceans, the shimmering waves, the endless depths, and the intricate webs of life they support. It's hard to believe that our planet wasn't always the lush, water-rich world we know today. In fact, billions of years ago, Earth was barren, an inferno of molten rock and fire devoid of the life-giving liquid we now take for granted. But how did this miraculous transformation occur? How did Earth's dry and hostile beginnings give rise to vast oceans teeming with life? This is one of science's most intriguing mysteries, a cosmic detective story that spans billions of years. Today we'll dive into the extraordinary tale of how water came to Earth, our source of life, and the very reason we call our planet home. To truly understand the origins of Earth's water, we must start at the very beginning, 4.5 billion years ago. Back then, Earth was a chaotic, hostile young planet. Constant volcanic eruptions spewed lava and toxic gases into the atmosphere. Giant asteroids bombarded its surface, adding to the chaos. This was a planet in the making, a fiery wasteland that, at first glance, seemed incapable of sustaining oceans, let alone life. During this period, there was no water to be found on the surface. If you could travel back in time, the Earth you'd witness would be unrecognizable. A dry, barren rock orbiting the sun, devoid of the blue seas that make it so distinct today. So, how did this desolate landscape come to host the largest oceans in our solar system? The answer leads us beyond Earth, to the very origins of the solar system itself. Scientists theorize that the story of Earth's water may have started long before the planet even existed, deep within the cold, dark regions of space. In the early days of the solar system, it was a whirling disk of gas, dust, and ice. Among this cosmic debris were the building blocks of everything we see today, including the tiniest grains of frozen water. As the planets formed, gravity pulled these materials together, creating massive collisions. It's believed that some of Earth's water came from icy bodies, comets, and asteroids, which impacted the young planet. These space travelers carried frozen water in their cores, delivering it to Earth with every collision. Imagine icy comets careening through space, slamming into Earth's surface at unimaginable speeds. Each impact delivered small amounts of water to its surface. Over millions of years, enough of these collisions may have occurred to contribute to the eventual formation of oceans. Asteroid belts closer to the Sun also contained hydrated minerals, rocky bodies that trapped water within their chemical makeup. These too could have delivered essential material to Earth through similar violent encounters. To this day, scientists study the chemical signatures of water in comets and meteorites to trace their connections to the water in our oceans. But it wasn't just outer space playing a role. Earth itself had powerful contributions to make. As the planet cooled and solidified, volcanic eruptions became key actors in the formation of water. Deep within Earth's mantle, chemical reactions involving hydrogen and oxygen produced water vapor, which was released during eruptions. Over time, this water vapor accumulated in the atmosphere and began to condense as the planet's temperature dropped. When conditions were just right, it rained. And it didn't just drizzle, it poured for millions of years, filling the depressions in Earth's surface and forming the first oceans. This deluge of water transformed Earth forever. The once hostile wasteland gave way to dynamic oceans that began carving the planet's surface through erosion and sedimentation. These waters would later facilitate the development of weather patterns, create coastlines, and provide the foundation for ecosystems. But this remarkable transformation wasn't solely due to volcanic activity or celestial impacts. It was a combination of many processes working together across billions of years. So why did Earth succeed in holding on to its water when its neighboring planets, like Mars and Venus, were less fortunate? Several factors make Earth unique. First, its distance from the Sun places it in what scientists call the Goldilocks zone, a region where temperatures are just right for liquid water to exist. Earth's gravity, too, has played a crucial role, allowing the planet to retain its atmosphere and, in turn, its water. Finally, Earth's magnetic field protects it from harsh solar winds that could otherwise strip molecules like water vapor away into space. Once water settled on Earth, another miracle occurred. it became the crucible for life itself. In these ancient oceans, single-celled organisms began to emerge. The waters provided a stable environment for complex chemical reactions, giving rise to the first primitive forms of life. Water also acted as a solvent, allowing molecules to mix and interact in ways that would have been impossible on a dry, rocky planet. Over time, these early life forms evolved, thriving and diversifying within the seas. As Earth's story continued, water didn't just shape life. It began to influence the planet's climate, geology, and ecosystems. Oceans became Earth's climate regulators, controlling global temperatures by storing and releasing heat. Water, constantly recycling through the hydrological cycle, made the planet dynamic and resilient. Even today, water is intimately connected to life. Its stability and abundance allow ecosystems to flourish, supporting everything from microscopic plankton to the largest whales in the ocean. Understanding how Earth's oceans formed isn't just about looking back, it's about looking outward. By studying Mars, Venus, and even icy moons like Europa and Enceladus, scientists hope to uncover parallels in other worlds' water histories. Why did Mars lose its ancient oceans? Could Europa's icy crust conceal vast underwater seas teeming with life? The answers to these questions will not only shed light on our own water origins, but also help us search for life beyond Earth. While scientists have pieced together much of Earth's water story, some mysteries remain. Was space or Earth itself the largest contributor? How much water came from asteroids versus comets? Advanced techniques like isotope analysis and spectroscopy are helping to close the gaps, but the origin of Earth's water is still an evolving field of study. Stories like this remind us of how interconnected everything in the universe truly is. The tiniest droplets of water formed in the icy depths of space eventually became the oceans that cradle life on Earth. As we expand our understanding of water's cosmic journey, it deepens our appreciation for the fragility and uniqueness of our planet. Water makes life possible, not just here, but perhaps on other worlds awaiting discovery. Billions of years ago, Earth was a barren, fiery world. Today, it is a thriving blue planet, a testament to the extraordinary processes that shaped it. Oceans, born of cosmic ice and volcanic steam, transformed not only Earth's surface, but its destiny as a harbor for life. As you look out at the sea or admire Earth from space, consider this. Every drop of water has traveled an astonishing journey, from the ancient void of space to the oceans that sustain us today. That water tells the story of Earth itself, a planet unlike any other.